Welcome back to Differential Calculus class. So we are still on rules of differentiation. So in this class, I'll be teaching you how to apply the rule of sums and the rules of sums and differences in differentiation. So let's assume we have a function that is given, say f of x equal to, let's say we have g, we have a function, then plus another function. So let's say we have h that also depends on x. So this is for the sum. So how to apply the rule? The rule of sum simply implies that to find the derivative of this, so we are to find the derivative of this, that is f prime x, that is the derivative of this function, simply imply derivative of each of these functions. In other words, we differentiate this function, we also differentiate this function. That is, the sum of the derivative of this will give the derivative of the whole function. In other words, we are going to differentiate this with respect to x, then we have it to differentiate this with respect to x. Also, this is a sum. Okay. Also, if we give the same thing, let's say we have a given f of x is equals g x, then we have minus. This is differences. So the derivative of this simply implies the difference between the derivative of this. In other words, we have derivative of x, the function of x implies derivative of this, then minus the derivative of the second one. Okay, these are the rules of sums and differences. So let's take a look at some examples. Okay, don't get confused with this function we use. Okay, so in some textbooks you will see some, instead of g you might see maybe u. Okay, here you have b, so it's still the same thing. You have u and you have b. Okay, so you have u, you have v, here you have u, you have v here. So it's the same thing. Okay, so we can use g and h or u and v. So we are still talking about the same thing. So let's take a look at some examples. Let's take a look at some examples using some functions. So let's assume we have these very examples. So let's say we're going to find the derivative of, let's say we have the first one, let's say y equals 2x squared plus 5x, maybe minus 2. Okay, so if you have to find, let's say the second one, let's say we have f of x, let's say we have fx equals, let's say we have x raised to the power 3 minus 2x squared, let's say, plus 5x. Okay, as the case may be, let's say we have something like this. So now solution. So applying this rule, we are going to differentiate each of these components. So now the first one, we have the y, the x. So don't forget, this is a power function. Okay, adding to, we have a power function added to a linear function. So we are going to apply the power function rule here. So we bring down the power, so we multiply by the coefficients. So don't forget, that's 2 times 2, that is 4. Then I have x, then I subtract 1 from the power, so I'm left with 1 here. Okay, then plus, don't forget, this is a linear function. Okay, so apply the rule of linear function, so the differentiation of a linear function. Okay, so simply implies the coefficient of that variable, so we have plus 5. Okay, so we have done with this. So for the second one, so So we also have to differentiate this. So we bring down the power. So we have the coefficient of x here, which is 1. 3 times 1, that will be 3. Then we have x. We subtract 1 from the power, because this is the power function. So we are left with 2. Then, look at this another function, power function. We have minus. Then we bring out the power, 2 times 2, that is 4. Then we have x. We subtract 1 from the power, we have 1. Then we have plus. This is a linear function. So, division of linear function, remember, so dimension is the coefficient of that variable itself, so we have 5. So, this is it. So, can you try this? Exercise. So, let's say we have the first function, let's say we have f of x equals 2x raised to the power 4 minus 5x squared minus 2. Okay, so let's say we have y equals, let's say x raised to the power minus 2 plus 5x plus 2. So can you try this? Tell me the answer in the comment section.